All right, right now we're going to be doing question 4.2a. Now 4.2a and 4.2b are the same exact questions, just different numbers. And 4.2c is exactly like the second part of this question that we're going to do now. So there's no need to do multiple videos. We'll just do one. So it says we have a 50 kilogram object, or in this case a chair. It's pretty large actually. So kilogram object, and it starts from at rest on the horizontal floor, requires 364 newtons to set it in motion. Once the chair is in motion, 328 newtons is required to keep it moving at a constant velocity. All right, so for part A, we're just trying to figure out what is the coefficient of static friction. So this is the force applied is 364. The object's going to be in vertical equilibrium, so we're just going to make that Fg. And up here, normal force, it's, well, these two are going to be the same. And now, because the object is in equilibrium, this and the force applied is going to be equal to negative 364. The force of friction is going to be negative 364, but how do we know that? Well, based on the directions, it says starting from rest, and it's moving at a constant velocity. So constant velocity means equilibrium. Equilibrium means the F net is equal to 0. So let's do F net x is equal to Fa plus the force of friction. Fa is equal to 364. That's equal to 0. Therefore, the force of friction is equal to negative 364. The F net y is equal to the force of gravity plus the normal force. That's equal to 0 because it's in vertical balance. How do we know that? You always assume that these two are in balance unless otherwise stated in the directions, and that goes for most problems this year. That's mg plus Fn. The mass is 50. Gravity is negative 9.8. It's equal to 0. So that means just do 50 times. So we got 50 times negative 9.8. It's negative 490. Okay, which means that this is, no, I'm sorry, I apologize. The normal force, that's the weight. The normal force is going to be positive of that. So this will be negative 490, and this will be 490. Now, so with this being equal, because it's at an equilibrium, so the force of friction is equal to negative 364. Now, this one up there, this here. So the force of friction is equal to mu times the normal force. Try to figure out the static friction. This is going to be an absolute value. So 364 is equal to mu times the normal force. Now the normal force is 490, which means the coefficient of friction is just equal to 364 divided by 490. 364 divided by 490. 0.743. Now, question 4.2b is the same exact thing, both A and B, so same question. Now let's do part B. Now 4.2b, part B, and 4.2c are exactly like 4.2a, part B, so it's like the same exact video required. So for this one, the only thing that's going to be different is for the kinetic friction. If we go back to this original drawing, instead of this being 364, this is going to be 328, and this will be negative 328. And if you wanted to, like, that would be 328. So the force of friction is the same, so there's no need to do it again. So we got the force of friction is going to be equal to 328, and the normal force is still 490. That hasn't changed. So we do 328 divided by 490, 0.669.